Okay, hey guys, this is Mrs. Keith, and I'm doing notes over tangent, cotangent, secant, and cosecant today. If you hear a lot of yelling, it's because my husband and son are watching the Georgia-Alabama game right now, so it can get kind of loud, and I apologize ahead of time. All right, so when you're doing the tangent and cotangent graph, you want to use these as your angles for your table. And the reason why we're including more than just our quadrantals is because these angles right here, where you have pi over 4 and 3 pi over 4 and 5 pi over 4 and 7 pi over 4, that's where you can get the tangent value is 1. Remember, tangent of an angle equals y over x. And so when you do this y over this x, you're doing the same thing over itself, which gives you the value 1. And so those pi over 4s get you 1 on your graph. So if I do a table, remember x is the angle. So if we start off with the angle 0, and if I do y over x, I'm going to do 0 over 1, which is just 0. Then I'm going to do pi over 4. And when I do y over x, I get 1. When I do pi over 2, and remember your equation is y equals tangent x. So you're plugging in these x values into that equation to get what the tangent of that angle is. So pi over 2, I'm doing this y over this x, which would be 1 divided by 0, which is undefined. And then we're going to do 3 pi over 4. The reason why that's undefined is because you can't divide by 0. Okay, 3 pi over 4 will be negative 1. Pi will be 0. 5 pi over 4 will be positive 1. 3 pi over 2 will be undefined again. 7 pi over 4 will be a negative 1. And then 2 pi will be back to 0 again. So looking at this table, everywhere that you see an undefined, that should be where an asymptote is. So we're going to draw those asymptotes first. So hopefully you notice that you have an asymptote every pi units. Anywhere the x value is 0, that should be where you have an undefined value. So if I go the clockwise direction to get the angles, this is negative pi over 2, which is going to have the same value as this. So at negative pi over 2, we should also have an asymptote because it'll be undefined there. This up here will be, this is a negative pi right here. This is a negative 3 pi over 2, which would also be an asymptote because, again, you have a 0 for your x value. So you have an asymptote. The way we could think of that is we have an asymptote starting at pi over 2, and then we have another one every n pi units, where n is the set of all integers. So if we plug in numbers like 1, 2, 3, 4, negative 1, negative 2, 0, n for n, that'll be where an asymptote is. All right, so then to graph some other points, looking at our table here, at 0, 0, we have a point. At pi over 4, we have a point at 1. So pi over 4 should be halfway between 0 and pi over 2, so there should be a 1 right there. Then we have an asymptote. At 3 pi over 4, we have the point 1, which is right. Or I'm sorry, it's the negative 1 down here. At pi, we're at 0. And then at 5 pi over 4, we're at 1. And then we have an asymptote. And then at 7 pi over 4, we're at negative 1. At 2 pi, we're at 0. And then we'll have another. If you'll notice, every pi over 4, we're changing from 1 to 0 to negative 1 and so on. So this will be 1 right there, which means that right here will be a negative 1. So in between each of the asymptotes, you should kind of see what looks almost like a cubic graph for the tangent. So right here, that'll be 1, 0, and negative 1. So it should kind of go like this. And over here, should look like that. And we only care about you graphing 2 periods. Remember, a period is when you see the whole graph and then it repeats itself. So this represents 1 period, this is a 2nd period, this is a 3rd period. I've graphed 3 here. Okay, so some things I want you to think about is the fact that between 0 and pi over 2, that's quadrant 1. Between pi over 2 and pi, that's quadrant 2. What I'm looking at is, right here is quadrant 1 from 0 to pi over 2. Quadrant 2 is from pi over 2 to pi. And then, so this is quadrant 2. This is quadrant 3, which is between pi and 3 pi over 2. And then from 3 pi over 2 to 2 pi is quadrant 4. And remember whenever we did our all students take calculus, the two quadrants where tangent is positive is in the third quadrant and the first quadrant. So we should see that we have the graph above the x-axis in the first quadrant and in the third quadrant, which we do. And then in quadrants 2 and then 4, it ends up being negative right there. All right, so that is the tangent graph. So some things that you should notice is that your domain is all real numbers except for where you have these asymptotes. Your range is all real numbers. You have x-intercepts here at pi, at 0, at pi again, at 2 pi. So every pi units you have an x-intercept. So let me scroll this down a little bit. Okay, so what I want you to see here is these are the properties of the tangent graph. The domain, the way we would write this is that it's all real numbers except for x cannot equal. You have an asymptote starting at pi over 2, and then you have one every n pi units. N just has to be the set of all integers. And then that's supposed to be like a Z looking thing with a double thing right there. Let me see if I can make that look better. Pi, that has to be the period of your function. So this is the period right here. So if your period is changed, that value will change. Range is the set of all real numbers. This is an odd function. We talked about when we first started doing these graphs that we have even functions were cosine and secant, whereas all of the rest of them were odd. So sine, cosecant, tangent, and cotangent are all odd functions. The tangent function has a period of pi. So tangent and cotangent are the only ones with a period of pi. All of the rest have a period of 2 pi. All right, let's see what the graph of cotangent looks like. Okay, for cotangent, I'm going to use these same points. At 0, remember cotangent of an angle is the reciprocal of tangent, so it's x over y. So looking at your ordered pairs, I mean, if you look at this ordered pair right here, my ordered pair is 1, 0. So if I do x over y, I'm doing 1 over 0, which is undefined. So the cotangent of 0 is undefined. At pi over 4, that's where both tangent and cotangent will be 1. So every one of these pi over 4s, the tangent and cotangent is 1. You just need to think about if it's positive or negative in each quadrant. This is in quadrant 1, pi over 4 is. 3 pi over 4 is in quadrant 2, where tangent's negative. 5 pi over 4 is in quadrant 3, where tangent's positive, and then 7 pi over 4 is in quadrant 4, where cotangent's negative. All right, pi over 2 is using this ordered pair, so when you do x over y, you get 0. At pi, we have undefined again, because we do negative 1 divided by 0. At 3 pi over 2, we have 0, and at 2 pi, we're back to undefined again. So every one of those that's undefined should be an asymptote, which starts here at 0. And then you have another one at pi. And you should notice that you have an asymptote at every pi units, which again is the period of tangent and cotangent. So you'll have another one over here at negative pi and another one over here at negative 2 pi, which means that my domain is all real numbers except for x cannot equal. We started with our first asymptote at 0, and then we have one every pi unit. So we'll say n pi there, where n is the set of all integers. The range is all real numbers for tangent and cotangent. It is an odd function. The period for tangent and cotangent is always pi until you do some sort of transformation. So looking at our points over here on our table, at pi over 4 we have a point at 1, and then at pi over 2 we're at 0, and at 3 pi over 4 we're at negative 1. So it does this, kind of the cubic graph that's been reflected. And then over here it should be 1, 0, and negative 1 every pi over 4 units. And I've graphed 2 periods now, but I'm going to do a little bit more. So 1, 0, and negative 1. Okay, so I graphed 3 periods. So if you'll notice, you have x-intercepts at every odd multiple of pi over 2, or every pi over 2 plus n pi, comma 0 as an x-intercept. You have vertical asymptotes at 0, that's where the first one starts, plus n pi. Again, we get that number right there, the pi, from whatever your period is. And that's the cotangent graph. Some other things to notice is that, from 0 to pi over 2, that's quadrant 1. From pi over 2 to pi, that's quadrant 2. And then we've got quadrant 3 and quadrant 4. And remember, tangent and cotangent are both positive in the first and third quadrant and negative in the second and fourth. So it should be positive here in quadrant 1 and it should be positive in quadrant 3 again. And then in the other two quadrants it should be negative, which it is. So we've graphed that correctly. All right, let's look at secant and cosecant. Okay, when we graph y equals cosecant, we need to first focus on what y equals sine of x is, because remember, cosecant x is the same thing as 1 over sine x. So focus on what sine x looks like. So looking at your unit circle, which I've drawn here, when we do sine of 0, we get, you remember on the unit circle, the y values are your sine. We get 0. When I do sine of pi over 2, I get 1. Sine of pi is 0, and then 3 pi over 2 is negative 1, and then 0 again. So then this column will be the cosecant table, or this table over here will be the cosecant table. And remember, it's a reciprocal of sine. So we're looking at these numbers right here to figure out what to put over here. So when I'm going to do the reciprocal, this is understood to be 0 over 1, so I'll flip that to be 1 over 0, which is undefined. So it's undefined there. At pi over 2, that's 1 over 1, because that's understood to be over 1, and when you flip that, you get 1. When I do 1 over 0, I get undefined again. This will be negative 1, because I'm doing 1 over negative 1, and then 2 pi will be undefined again, because it's 1 over 0. So when we graph the cosecant graph, it's a good idea to always graph this graph first, the sine x. So what I'm going to do is kind of plot all those points. At 0, we have a point at 0. At pi over 2, we have a point at 1. At pi, we're at 0 again. At 3 pi over 2, we're at negative 1. And at 2 pi, we're here. And then remember, you can go the clockwise way to get the negative. So this will be in negative pi over 2, which is at negative 1 for the sine. And then 0, 1, and negative 2 pi. All right, that's the sine graph. I'm going to go ahead and just kind of do a dash graph. It's really not what we're wanting to see. I just think it helps to kind of visualize what the sine graph looks like. It's really not the cosecant graph at all. So everywhere that you see that the sine graph is crossing the x-axis or where it's 0, those are asymptotes for the cosecant graph, because that's where it's undefined. So they're at 0, and then again at pi, and then again at 2 pi. And then over here at negative pi, and at negative 2 pi. And then the rest of the cosecant graph is everywhere you see like this highest point, you're going to draw what looks like a parabola on top of that. And if it's the highest point, it's going to be a parabola that's going up like this. If it's the lowest point, then you're going to do a parabola going down like this. And those parabola-looking things are between those asymptotes. So here's another one here, and here's another one here. So this represents one period, and this represents the second period. Remember, a period is whenever you do the graph, and then when it repeats exactly, that's the second period. So hopefully you'll see that it takes you a full, from here to here, that's one period. It took you 2 pi units to make that happen. So the period of the cosecant graph is 2 pi. So to get the period, you always do 2 pi divided by b. You don't have an amplitude for any. The only two functions that have amplitudes are sine and cosine. The rest of them do not. But that's what the cosecant graph looks like. All right, let's do secant. Okay, looking at secant, we need to do the y equals cosine graph. So on your unit circle, those are all the x values. So at 0, it's 1. At pi over 2, it's 0. At pi, it's negative 1. 3 pi over 2, it's 0. And at 2 pi, it's 1. And then when you do the table for secant, it's just the reciprocal of each of those, because secant graph is the same thing as 1 over cosine. So this will be 1 over 1, which is 1. This will be 1 over 0, which is undefined. This will be -1, undefined, and 1. So I usually graph the cosine first. So you have this point right here at 0, 1, at pi over 2, 0, -1. Just kind of graphing each of these. All right, so that's the cosine graph. The secant graph, everywhere you see, oh, I think I messed something up, didn't I? I totally did. Let me erase that. Sorry, I messed that up. Let me graph that better. Sorry about that. So at 0, 1, we had a point at pi over 2, 0. Pi, we're at -1. At 3 pi over 2, we're at 0, and then we're back to 1. And then here we're at 0, and then -1, 0, and 1. Sorry about that. Okay, so now then the secant graph will be the reciprocal of this cosine. So everywhere you see it cross the x-axis, that will be an asymptote. So every pi units, you have an asymptote here. Okay, and every hump, or like the highest point for the cosine graph, you'll have a parabola on top of it. If it's the highest point, it goes up. If it's the lowest point, it goes down. So this one will be one that goes down. Technically, I didn't finish this one, but it would look like this. There's another asymptote right here. And then over here, it'll look like this. Another asymptote right there. So that's the graph of the secant. And I've graphed about 2.5 periods there. So you had asymptotes at, the first asymptote was at pi over 2. And then you had one every n pi units, where again, n is the set of all integers. All right, let's do some transformations. All right, the tangent graph. This lists all the transformations. A is your vertical stretch. B changes the period, and because my original period is pi, I'll do pi divided by b to get the period. C is your horizontal shift left or right, and D is your vertical shift up or down. So in this one, on the first example, we have changed this number right here, which is my b value, the number that's being multiplied times x. So that's going to be a horizontal compression by 1/2. Remember, it's always opposite when it's with your x. So remember, for the tangent graph, we always do, we include the pi over 4. So I'm just going to do one period. So I'll do 0, pi over 4, pi over 2, 3 pi over 4, and then pi. That's one full period. So the tangent of 0, if you remember on your unit circle, right here is 0. That's the order pair 1, 0. So the tangent is y over x, which will be 0. At pi over 4, it's 1. At pi over 2, which is right here, is the order pair 0, 1. So you're doing y over x, which will be undefined when you do 1 over 0. 3 pi over 4 is -1, and pi will be right here, which is at the order pair -1, 0. So 0 over -1 or 0. So you have an asymptote at pi over 2, normally, but not in this case. Hang on, let me fix that. So what I forgot to do is I showed the transformation. So on the x right here, you're going to make changes to it by doing the opposite. Instead of multiplying by 2, we're going to multiply by 1/2. And so this will stay 0 because you're doing 1/2 times 0, which is 0. 1/2 times pi over 4 is pi over 8. Half of pi over 2 is pi over 4. Half of 3 pi over 4 is 3 pi over 8. And half of pi is pi over 2. So normally we had an asymptote at, it started at pi over 2. And then you had one every, using the period, which is normally pi, we had one at every n pi units. But we've changed our period for this one because we would do pi over 2. So this time we'll have an asymptote at, our first one is at pi over 4. And then you should have one at every n times pi over 2, because our period is now pi over 2. So if you'll notice, they're counting in pi over 4s on the x-axis. So that's my first asymptote. I'll have another one. That's when n is 0 and we have the pi over 4. If I add pi over 2 to that, I get 3 pi over 4, which is right here. So that would be another asymptote. And then you'll have another one at 5 pi over 4. And then another one at 7 pi over 4. And then you have the point 0, 0 right here. At pi over 8, we're at 1. At pi over 4, we have the asymptote. At 3 pi over 8, we're at -1. And then 0, and then it should be 1 here. So you should see those cubic functions still within the asymptotes. And then it just kind of alternates. Every pi over 8 units, you should see it alternating between -1, 0, and 1. My dogs are snoring again, sorry. Okay, so there's 3 periods graphed right there. So hopefully you can see that this right here represents 1 period. And so I've graphed 3 periods here. Okay, so this next one, we're doing the cotangent graph. Remember, y equals cotangent x on the unit circle is x over y. So for the original table, for each of these, for 0 right here, it would be undefined. At pi over 2, or I'm sorry, at pi over 4, it's 1. At pi over 2, it's 0. At 3 pi over 4, it's -1. And then at pi, it's undefined again. And then the transformations that we're making is we're going to multiply the y's by 2. And on the x's, it shows that this is understood to be 1/3 times x. I could rewrite that as 2 times cotangent 1/3 x, which means instead of multiplying by 1/3, we're really multiplying by 3. So that's 0, and then 3 pi over 4, and then 3 pi over 2, and then 9 pi over 4, and then 3 pi. So undefined times 2 is still undefined. That's 2, 0, -2, and undefined. All right, so at 0, we have an asymptote. At 3 pi over 4, we have the number 2. At 3 pi over 2, we're at 0. At 9 pi over 4, we have a -2. And then right here is 3 pi. At 3 pi, we're at undefined again, so we have another asymptote. So remember, our period is pi divided by b. We're doing pi divided by 1/3, which is really pi times 3 over 1, or 3 pi. So my period is 3 pi, which means that you should see that you're repeating every 3 pi units. And so this is the cotangent graph that has been horizontally stretched by 3, and it's also been vertically stretched by 2. So 1, 2, 3, 4. Right here is -3 pi. We should see another asymptote because we have them every 3 pi units now. Halfway, you'll have a 0 right here. You'll be at 2 right here, and then you'll be at -2 right here. All right, that's 2 periods graphed. Okay, for this one, I've done the original table for tangent. To each of my y's, I'm going to multiply them by 3 because of this 3 right here, and I'm going to add 4. And so this becomes 4, 7, undefined, 1, and 4. And then to your x's, you're going to do the opposite of what's here. So instead of dividing by 2, you're going to multiply by 2. And that's the only change on x. So this will be 0. 2 times pi over 4 is pi over 2. 2 times pi over 2 is pi. 2 times 3 pi over 4 is 3 pi over 2. And then 2 times pi is 2 pi. All right, so at 0, we're at 4. Basically, remember, you have that midline, which is kind of like your x-axis. It's moved up here to 4. if that kind of helps you visualize this. We have an asymptote at pi. So normally, we have an asymptote at pi plus every n, and then whatever your period is. In my period, I get by doing pi divided by b, which in this case is 1/2. And when you divide pi by 1/2, you get 2 pi. So you should have an asymptote every 2 pi units past that. So then you'll have another one. Right here is 3 pi. You'll have another one at 3 pi. And then you'll have another one over here at negative pi. And then another one over here at negative 3 pi. All right, so at 0, we're up here at 4. And then at pi over 2, you're going to be at 7. And then looks like the lowest it'll go will be at 1. And that should be over here at negative pi over 2. So this should be your graph. And then at 3 pi over 2, we're at 1. At 2 pi, we're back to 4. And then right here, we should be up here at 7. And then, just continues from there. There's 2 periods graphed, though. All right, let's do another one. Okay, for this one, for secant, I'm going to do the graph of cosine first, because secant's a reciprocal of that. So at 0, we're at 1, and then 0, and then negative 1, 0, and 1. You're going to do your transformations on that. So my y's were changed by multiplying them by 4 and then subtracting 4. My x's were changed by multiplying them by 2. This 1/2 right here, do the opposite of it, so multiply by 2. So this will be 0, pi, 2 pi, 3 pi, and 4 pi. So your period for the secant is 2 pi divided by b. We're going to do 2 pi divided by 1/2, which is the same thing as 4 pi. So that will be our period, 4 pi units. So this gives me 4 minus 4 is 0. 0 minus 4 is a negative 4. Negative 4 minus 4 is a negative 8. 0 minus 4 is negative 4, and 4 minus 4 is 0 again. Okay, so I'm going to graph the cosine graph first, just kind of making it dashed. So we have a point at 0, 0, at pi, negative 4. At 2 pi, we're at negative 8. Remember, we kind of have this midline that has now shifted down here. So for the cosine graph, that's your midline. Your lowest point will be negative 8. Your highest will be at 0. So at 4 pi, or at 3 pi, sorry. This is 3 pi. We'll be back to negative 4. And then at 4 pi, 1, 2, which is about right here, we'll be back to 0 right here. And you're kind of continuing that on. Every pi units, you should see it's either going to the midline or the highest point. So this is a negative 3 pi here, which puts us back at the midline. And then at negative 4 pi, which is here, we'll be back to 0. So I'm going to kind of draw the cosine graph. Okay, so now then, things to do for the secant graph. Normally, every time the cosine graph had a y value of 0, that's where we had an asymptote. So this is now where the asymptote will be, when the cosine graph is crossing that midline. So right here will be 1, right here will be another, right here will be another, and then right here at 3 pi will be another. So you have asymptotes. Your first asymptote would be at pi, and then you have one every, it looks like 2 pi units, so n times 2 pi. So the secant and cosecant have twice as many asymptotes in one period as the tangent and cotangent. So basically this will always be half of a period. All right, so then your secant graph will be those parabolas that are on each of the high points and low points of the cosine graph. right, so that's 2 periods graphed there. And technically you have another one over here. All right, let's do another one. Okay, so I have graphed or done a table for y equals sine of x because we're doing cosecant, and sine x and cosecant are reciprocals. The changes that I'm going to make to the x and the y's I'll multiply by 2 and then add 2. The x's I've gone to the left pi over 2, so I'll do x minus pi over 2. It's always opposite when you're with the x. So this will give me 2, 4, 2, 0, and 2. I'm going to do 0 minus pi over 2. I get a negative pi over 2. Pi over 2 minus pi over 2 is 0, and then pi over 2. 3 pi over 2 minus pi over 2 is pi. And then 2 pi minus pi over 2 is 3 pi over 2. So I'm going to graph that sine graph there. And basically you should think about how your midline has now shifted up to 2. So you'll be alternating. I mean, your lowest point will be 0, your highest point will be 4, because you have an amplitude of 4. An amplitude of 2 for the sine graph. So at 0, we're up here at 4. At pi over 2 will be at 2. And then at pi, we're back to 0 again. And then here we'll be at the midline, and then at 2 pi we'll be up here at 4. And then over here we'll be at negative pi. And then up here at 4. So graphing this. It looks like that. Okay, so now remember that the cosecant graph, it would have an asymptote anywhere. Your sine graph was originally 0 because the cosecant will be the reciprocal of that. So anywhere that your sine graph crosses the midline will be where an asymptote is for the cosecant. So these are all asymptotes. Remember, your period is 2 pi divided by b. Your b value is 1, so your period is just 2 pi. So you're going to have an asymptote starting at pi over 2, and then plus n times half of the period. So every pi units, you should have an asymptote after pi over 2. All right, and then you have those parabola-looking things on each of the high points and low points of the sine graph. So the red part is the cosecant graph. And then I've graphed 2.5 periods there. All right, one more. Okay, for this one, I've done the graph or the table for cotangent. I'm going to multiply the y's by a negative to show that reflection right there. So remember your cotangent graph, originally it looks like this. When you reflect it, it's going to reflect over the x-axis, and so it's now going to look like this. Kind of like the tangent graph that's been shifted to the right. But then you also have some other shifts going on here as well. So you'll multiply by negative 1, and then you'll also subtract 3. So this will be undefined still. And then negative 1 minus 3 is a negative 4. 0 minus 3 is a negative 3. And then negative 4. I'm sorry. Actually, that is not right. So you're doing a positive 1 minus 3, which is a negative 2, and then undefined again. All right, and then the other thing that you're doing is you're changing your x by shifting to the left. So you'll say x minus pi over 2. Okay, so this will be a negative pi over 2. Then you're doing pi over 4 minus pi over 2. Pi over 2 is the same thing as 2 pi over 4, so it's a negative pi over 4. And then pi over 2 minus pi over 2 is 0. 3 pi over 4 minus 2 pi over 4 is 1 pi over 4. And then pi minus pi over 2 is pi over 2. So then let's graph some of those. So at negative pi over 2, we have an asymptote. So normally we have an asymptote at every pi units because that's your period. So here my period, I do pi divided by b, which is still just pi, because in this case your b value is just 1. So I'll have one at every pi unit, so I should have another one at pi over 2, another one at 3 pi over 2, Over here, another one at negative 3 pi over 2. Okay, and then at negative pi over 4, we're going to be at negative 4, which is right here. At 0, we're at negative 3. And then at pi over 4, we're at negative 2. So you should be seeing that repeated throughout. So right here will be negative 4, 0, negative 3, negative 2. So there are 2 graphed. I'm going to do one more. All right, so hopefully you can see that's the cotangent graph that has been reflected. It's been shifted to the left, and it moved down 3. All right, that's it for these notes. Thanks, y'all.